engineers there. Great. Thanks for coming today. My name's Mike, and this is Paul.
Hiya.
We're talking today about mobile web development, how you can go from a zero, that's your very basic raw web app, all the way up to a hero on the various mobile devices. You can see up there we've got feedback links, and on the bottom of each slide we've got the link to Moderator 2 if you want to ask any questions. So, let's see. So HTML5 is here, and it's mobile. You've heard a lot about HTML5 today, of course, in the keynote and some of the other talks. I'm not going to spend ages convincing you about the benefits and the power of HTML5. What I will say, though, is that HTML5 is also here on the various mobile form factors. Many phones today and tablets and so on, they all support quite advanced HTML5 browsers and runtimes. And we think that mobile is an awesome platform to be looking at if you want to reach many of these users. Firstly, mobile is a very convenient form factor for people. It's something that people can actually use when they're standing in a line, when they're sitting on the couch or in the pool, as the case may be, and they've always got it. And if you want your people to be always using your app, that's a great way, is to have it somewhere where it's always at the person's fingertips. It's also a very personal sort of form factor. People tend to have one particular device that they've always got with them at all times, and they've got all their personal data and all their friends and so on it. So you get that kind of relationship with the user by being on the device. Mobiles are also a very natural sort of form factor these days. It wasn't always the case, but now the kind of device that we're carrying around with us happens to be a device that's very much touch-based, and that's the way that humans have always worked. We like to manipulate things with our hands, much more natural than being hunched over with this superficial kind of very recent in the scale of things invention of a keyboard. So actually being able to hook into that and actually working our apps to be natural and feel with that sort of tactile sort of user interface is a big win. And probably the most important thing for you guys as developers is the fact that mobile is an insanely popular platform at this time. Many people here, probably actually everyone here, actually has at least 2 mobile devices as of yesterday, because you almost all have a mobile phone, and you all now have a tablet as well. And I'm guessing there are probably people here with 5, 6, and 12 mobile devices. So that's just individuals, but there's also people across the whole world who don't have any other computing device. The mobile is the main way they actually get connected with the rest of the world. The flip side to all these great awesomeness benefits of mobile is the development side of things can be a little bit of work. You've got all these different platforms. We love Android, but it's not the only mobile platform out there. There's still iOS, BlackBerry, and many more in this huge long tail of mobile platforms out there. And especially so when you consider the various form factors. This is not just about the phone that you carry with you anymore. This is about the older phones that other people might be carrying around, the traditional feature phones, and many of them do have some basic browsing capability. We want to be able to reach those users too. And of course, we want to scale up to those very advanced mobile platforms that we have now, like tablets. HTML5 then presents itself as a promising opportunity because the web runs on, as you know, traditional form factors like desktops and notebooks and laptops. We've been running browsers on these things for many years. But more recently, we've had the web running on all these mobile form factors as well, from phones and the much more advanced smartphones and tablets to the more exotic sort of devices like music players and ebook readers too. Most of these kinds of devices, and certainly any phone that you would actually get these days, any tablet, you would be astonished if it didn't have a browser. And in fact, many of these browsers are based on engines like WebKit, very sophisticated, advanced capabilities, and some of the benefits of performance and so on that we're actually starting to see in the desktop as well. So HTML5 as a platform, it does all these things. It does amazing user interfaces like you've seen today in the keynote. It does capabilities that are actually behind the scenes as well, the sort of networking and offline capabilities that have only been available to native apps until recently. we're starting to get to a point where we've got these comparable features in the HTML5 stack. So it is an awesome opportunity to actually take advantage of HTML5 to reach all of those mobile users and get all those benefits. But we have to think about these two aspects, which is firstly user experience. We want to hold our heads up high as HTML developers. We want to actually be able to say, yeah, this is actually a really compelling, rich multimedia experience, just like you're used to on modern mobile devices. And at the same time, developers, right? We're all developers here. We really care about making our life easier too. We don't want to have to end up writing 1,000,001 different apps for all of these different form factors. We want to think about ways to optimize between these two forces of user experience and developer experience.
So we've identified these kind of 6 fundamental challenges that you as developers today face building these rich, awesome user experiences for the mobile web. The first, and probably one of the most important, is different interaction styles. How do you build applications, and can you build applications that work across all the different types of form factors that we mentioned earlier? Can you build an application that works across the Opera Mini style devices, or tablets, smartphones, the whole range? Is it possible just to build one application that is deployed across all these different types of devices? Users expect their applications to load pretty much instantly and respond quickly to their gestures and commands. Is it possible to build applications that the types of speed and interactivity that we get from the native platforms on the mobile web? And we're all used to this. If we've used our web browser and we've been on a train or kind of a semi-permanent internet connection, we just can't use our web browser. But is it actually possible to build applications that work entirely when you're offline, or in the cases where you've got this kind of intermittent internet connection? Each of these devices has a marketplace or a store built directly into them. So, how can we get our applications discovered when we're building mobile web applications? Is it possible? If you look at the trend of browser development, you'll notice that the primary input mechanisms has always been keys and mouse. But with all these new types of devices primarily being touch-based, can we build applications that aren't just responsive to kind of single presses, but the rich gestures that we expect from native applications? So is that possible on the mobile web today? And we kind of have to forget about the different form factors. Is it possible to build applications that are responsive to the variety of different screen sizes that we see in just one class of devices, say smartphones or even tablets? They've all got fundamentally different size screens and resolutions. Can we build applications that look great on all these types of devices? So I have a question for you all. Raise your hand if you think we can solve every single one of these challenges today on the mobile web. I've got a couple of people, right?
A lot of confidence here.
Okay, so the kind of set theory, we can expand that a little bit easier. Can we solve any of these challenges today on the mobile web? A couple more people. Well, no, we can't.
Sorry.
So we have 45 minutes for questions. Has anyone got any? Of course we can solve these problems, and we're here today to try and educate you in ways that we think we can build these applications to take advantage of all the latest modern advancements in web browser technology, but also kind of give that user experience that users expect from applications, regardless of whether they're native or whether they're actually on the web platform. So I would like to introduce an application we've written today called IO Reader. It's a special demo application just for today. The code will be live at the end of this presentation. And essentially, it's a news reading application. It embodies all of the the problems that we face on the mobile web today. We want our application to work offline, but most web applications don't. And we think we've built our application to solve all these challenges. It's built using all the modern web technologies that we as kind of progressive web developers use today, so things like Node and Modernizer and everything. And without much further ado, we're going to jump into a demo. So we've built this application. It's on the mobile, the smartphone form factor. And if you've seen, oh, here we go, move it up. If you've ever seen the news and weather native application, you'll notice it looks quite familiar. We have the traditional kind of scroll inside the application. And then we can also embed, you'll click on, and read an article. We have the nice gesture support so we can fling articles. The really cool thing about this is we're actually using consistent URLs throughout this whole application structure. So we can take advantage of some native, some native capabilities, such as share. So we can share individual pieces of functionality or pages from our web app, the kind of things that everyone expects from web apps. We just built this application to take advantage of that. We have nice usage of the browser-based back button, and as you'll see, we didn't actually reload the page. The whole user experience was contained inside our application. It just kind of works really nicely. We've got the ability also to take advantage of gestures, like the gestures that we see on these native platforms, like swipes. And then we've also got some nice little piece of, hopefully this will work. Yep, so we've got a refresh functionality. The kind of things that we're starting to see in the mobile native platforms for, say, refreshing and reloading data, we've built that into this application too. It also supports device orientation changes. So again, we can still swipe between the articles. It's just a really nice example of an application which we've built just using plain HTML, JavaScript that works across smartphones. But as we said before, the mobile web isn't just about smartphones and building applications that work on phones. It's also about tablets. So the same application with the exact same HTML, 90% of the same JavaScript, is targeted to the tablet form factor. And as you can see, it's, well, the functionality is equivalent to the application that we had. We had the categories and articles. We had the dynamic loading of data into that article, so it's quick and responsive to your commands. But it's definitely optimized for the tablet experience. So we can go through these articles. The really cool thing is we had an engineer from the Mountain View office build this application. Mike actually built the smartphone application as well. And we didn't have to talk to each other too much. But yeah, we have this tablet application. It looks absolutely beautiful.
So I'm going to shift back here. So we actually just went through those 6 challenges that we've identified as the main challenges we think HTML5 developers need to solve if they want to actually make their apps work nicely on the mobile. And we've shown you these apps here. Oops. Smartphone and tablet. So we want to actually take you through now, how have we solved each of these 6 challenges? And the first of those challenges is dealing with different interaction styles. We want to actually make sure that we're actually looking at different form factors like the phone versus the tablet as not just about the fact that we've got extra screen width or extra resolution, but actually about the sorts of interactions people have come to expect. So I think you've already seen that with the phone, that it's the sort of thing you can just get quick information, click and do something. The tablet sort of interface is more about exploring and you get pictures, and it's that sort of more browsing experience, a bit more of a relaxed experience. And our intuition is we want to go across the board with each of our form factors, writing separate UIs and separate actual mini applications based on the common core. We start with the principle that we just have HTML. This is really how the web is supposed to work. It's supposed to work as structured, semantic content. And with HTML5, we get extra structure. We can actually have these tags like header and section, which give a bit more meaning to what's actually on the page. And this in itself is a great thing. This is actually what is sitting on the internet for this app. And when you've got that content sitting on the internet, people can make use of it. You've already got a kind of API without having to go and deliberately create one. It's something that people can make use of, and it's great for SEO and for accessibility. And it's also great for people who have these older kind of browsers as well. Anyone here use links? Okay, cool. A few fans. So this is the real version of links here. So we've got our app sitting in links. And let me see, I can open up an article. And it's quite readable, you know, from just a very basic browser. So our idea is that we can go from all the way up from the 0 browser to the hero browser. Likewise, we can actually do this with mobile as well. So we've got another demo here on Opera Mini. And Opera Mini, if you don't know, is a very basic sort of browser that does a lot of image compression and strips a lot of JavaScript to make it a very minimal experience for people who don't have high bandwidth. So our app works nicely on that too. Sorry, it's not very well lit up there, but hopefully you can see that. And same thing, you can then open up individual articles. So all based on that principle that you have just some bit of common markup and the whole thing works nicely without any JavaScript at all. But that's not, the benefit of that is not just about the fact that there are people using these browsers like Lynx and Opera Mini. It's also about just the fact that that's how we've architected our application. So we actually start with that common base, and then each of those layers can actually build on top of that. So that's our idea here, is we use this principle of progressive enhancement from the basic app. So we go from that very basic app, add these extra layers, to actually make it a compelling experience and one that's relevant to each of the form factors. We use the principle of feature detection to actually see if a single feature is there. If we can use it, then we'll actually go ahead and use it on this browser. So that's kind of the point about when we say that HTML5 runs so-called everywhere. It's not a magic bullet. It's not like saying you just create your app once and it's just going to magically work everywhere. That can sometimes be the case. But it's more about recognizing that you've got this common stack of technologies running on all of these different devices. And if you can put a little bit of intelligence in your app about dealing with these different types of devices, then you get the benefit of all the reuse of that common code base and the fact that you only have to learn about one set of widgets and one language. But we're going beyond the idea of feature detection in this talk, and we're introducing a concept that we're calling form factor detection. And our intuition being that you can't just algorithm away the distinction between a mobile and a desktop and a TV. You can't just say, oh, we're dealing with a TV now, so we'll just add an extra 27 columns to our Reader app. It's more about understanding what are the users trying to do. With a TV, it's a lean back, more of a lazy, perhaps a social experience. With a phone, it's I want the information now. With a desktop, it's something you might spend hours and hours working on. So you have to have qualitatively different sorts of interfaces for this, but you don't want to have a million different interfaces for every model and every device. So we're kind of trying to go for this happy medium here with the idea of a form factor and actually acknowledging that that's really the thing that we want to be targeting. So we've created this library called FormFactor.js, which basically does the best job it can to detect what's the current form factor this app is running in. If it's a phone, then it will load these libraries and JavaScript and CSS, and if it's a desktop, it will load these other ones. So you can build these small layers. That's what we're aiming for, is a big core of common logic, and you've already seen it with the phone and the tablet. They're using the same markup. They've got the same content for doing things like, or the same code for doing things like retrieving the actual articles that you've seen on the reader, retrieving the categories, caching them, actually being aware of what the user is doing. All of that is actually common code. And we create these small layers. We love to call them awesome layers for just very specific code that's relevant to the user interface. So this is the kind of thing you'll see if you actually look at one of those awesome layers. It's the phone, JavaScript, and it's able to respond to semantic events. So that's the contract that you have to conform to in our architecture if you want to actually respond to events like when the users just change the category, when the users change the article. You can actually jump in, you can actually provide some custom JavaScript, but a lot of that is taken care by the common code on both the client and the server. On the HTML and CSS side, we also have a pattern we use where we actually identify that there are particular states in our app. So as well as having distinct form factors, within our app, we have distinct states. We go from a menu state where you're seeing all of the categories and maybe a welcome screen, to a category state where you're looking at a single category like music and technology, and then we go to an individual article where you're actually reading the article. So whether you're looking at the phone or the tablet or even the very basic interfaces, you've always got those three states. And again, the contract is if you're writing a layer, you're going to fill in the CSS for how the app should look in that state. And by putting that class on the root element, you can actually define the entire CSS for your app, the entire style of each component in the CSS for that particular user interface, for that particular form factor. And we see that here. This is the kind of CSS you'll see for the phone, where it's doing things like, if we're in the article state, then we'll show the active article with overflow visible, so we actually show the extra content, and so on and so forth. We create all that style for each of those states. That's what you can do. And if you've already written the phone layer and you're going on to create the tablet layer, it's very straightforward. You know exactly what you have to do. You just basically fill in what do I need to do when I'm responding to those events in the JavaScript side, and what's the CSS like on the HTML and CSS side. We actually use a framework called Less instead of raw CSS. Less is one of several frameworks going around right now. That's a kind of CSS++. It's not a complete new language, but it just adds a little bit of syntactic sugar that we found very convenient for this sort of architecture, where you can see here, you can do what you can't do in normal CSS, which is you can actually have a hierarchy. Pretty intuitive. It's just the same as having article state before all of those things. Another benefit of these high-level CSS frameworks is we have the idea of macros, so no more repeating the same color code 27 times in your style sheet. We can actually have a single color palette style sheet, and we can then reuse that across all of the different form factors. So if we want to tweak our branding, we can just do that all in one place.
So how do we build applications that are quick, nearly instant to load, and then respond rapidly to the user's gestures and commands? Well, we built our application as a single-page app. The theory being behind this is, we don't want to have the user transition between article A, article B, and then have a 5-second delay with the white screen of the application doing nothing. It kind of really breaks that whole user experience, and isn't something that you see in native applications. Single-page apps aren't actually a new concept. If you've been doing a lot of kind of Ajax development recently in the past 10 years, 8 years, you'll be used to this type of thing, but it's really good on mobile-style devices because you don't exactly know what type of network that you're dealing with. It could be a low-latency network, Wi-Fi connection, or a high-latency network. So single-page applications, they keep all the logic and functionality inside that one page, but incrementally load all the data, and you just manage it through JavaScript. It's nothing amazingly special, but it really improves that whole user experience. As you saw earlier on from the links demo, our whole DOM, our whole object model for this application is, it's semantically it's semantically defined, so it's consistent across all these browsers. The main thing that you'll notice is, when we saw in the links demo, is you navigate from an article to another article. That navigation is just handled via normal links. So what you do with a browser that supports JavaScript and you want to keep them inside this single-page app, again, it's a very simple thing. If you ever used jQuery, you basically just hijack the browser click, do some of your custom business logic, so in this case a fetch article, and then just prevent the default action from occurring. I mean, we've been doing these things for quite a while. It's just one of those nice little things that we did inside our application that just really makes this whole experience kind of cohesive and inside that one page. But the question that everyone asks when you build these single-page apps is, well, single-page apps break the web because they don't allow you to deep link. They very rarely keep the state inside the URL. We kind of solved that by expanding our use of the history APIs. So it's kind of worth going through the history, a brief history of history, I suppose, of how actual browsers have managed navigation over the last couple of years. In 2000, when we were all building our Perl apps and everything, we had a URL structure that normally closely mimicked the directory and file structure. So you would have a category, and then inside that category you might say, well, this is a list of technology articles, and the server would actually render that out and send it to the client. But as Ajax took off and we started building applications which were pretty much inside this single-page container, we still wanted to have the ability to bookmark individual pieces of state. So you would use the hashtag, sorry, that's the Twitterism. You would use the document fragment syntax just there to kind of indicate some state and make it bookmarkable. But the problem, obviously, with using the document fragment is that the server never sees this data. So your application can't be built by the server in its entirety. You will load it in the browser, and then the browser will go and fetch some data. Again, not only because the server can't respond with all the data up front, the search engines were having like a whole load of trouble actually being able to parse the data in a consistent manner. So some search engines tried to standardize on a common format for using the document fragment syntax to indicate particular bits of state inside your browser. But that wasn't great. But if you look at the URLs that say, modern web developers are using today, they look pretty much exactly the same as they did in 2000. So what is the difference between now and then? Well, the main difference is the use of the HTML5 history API. It's a really simple API. It basically allows you to change the URL of the browser purely from the client side. As you can see from this code here, it's a simple command called push state. And you basically just give the browser the URL that you want it to be in the screen, the title, so it looks nice when you bookmark it, and maybe some application-specific state. We didn't need any particular JavaScript objects inside our app pushed into the history, but you can do that. And then as the user is navigating around the application using forwards and backwards buttons, there's an event that fires, pop state, which essentially you just hook into here. And in our application, we just chose to listen to the document location. You can actually do whatever you want inside this function. We just said, well, we're going to look at the document location, pass it out, then go and fetch the category data. So if the URL matched business, we would fetch the business data. But especially in a news application, you never know all of the URLs that your application will encompass. You might know all the categories, but you won't know every single article. So managing your code like this isn't great. So we made a framework called Levi Roots. It's on GitHub as well. We made a framework called Levi Roots, which is it's a basic URL routing framework. If you've ever used App Engine or Ruby on Rails, the syntax is relatively similar. But it basically allows you to define specific URL types inside your JavaScript, inside your client, and then respond to them with your own kind of custom business logic. So in our case, if the article looks like a category, or the URL, sorry, looks like a category, we go and fetch the category data. And then if the article, I keep saying this, if the URL looks like an article, we then go and fetch the article data. It's actually pretty simple, but it allows you to keep your application-specific logic to a minimum and just make it very readable. So we saw from the links demo, we were rendering data from the server. So all the application data, in our case, categories and articles, is being generated by the server. But also at the same time, we had these really rich interactive applications on, say, the smartphone and tablet where all the data was loaded into the client at runtime. So that presents a problem. You need to have potentially 2 templates, manage them in potentially different languages, whether it's Python and Perl, and then on the client side in JavaScript. How do you go about doing it? So we use a basic technique called dual-side templating, and we combine that with a framework called Mustache, which basically allows you to maintain one common template across client and server. And as long as your data format is consistent throughout your entire application, you can basically just render the same data. It substitutes all the variable names, renders some nice HTML, and then you present that to the client. Oops, sorry. Sorry.
I go.
Yeah.
Okay. So we're actually talking about offline here. You already saw some of the offline apps mentioned in the keynote today, like New York Times Reader and Sports Illustrated was mentioned. So this is possible now on the web. There are technologies that let us do it, and fortunately enough for us, there are technologies that allow us to do it in the phones and mobile devices as well. You've actually just seen that these apps actually work offline on the various devices. The first of those technologies, and there's really 2 of them that work side by side. The first is App Cache, and this is the ability to actually store the entire application logic on the device, just like you would install an app from the Android market, and it would be sitting there on your device. It will be there even when the user's not connected. To use App Cache, it's really straightforward actually. In the basic case, you just link to the cache manifest file from your HTML tag. And in the cache manifest, you simply list all of the assets of your app. And that's the JavaScript, the CSS, images, and so on. The first time the user visits your app, the browser will download all of the assets you've listed in the manifest. And the next time they visit it, it will immediately serve those assets. It won't even check to the server at all, so it will actually work offline. And every time you do visit, if you are online, it will keep checking, and it will download in the background all of the new assets whenever that one file changes. So if you are connected, all that ever happens is just a single request to see if the cache manifest has changed. And if you're offline, the application keeps working as normal. The other side of this is storing actual data, which might be, for instance, an email the user is composing. In this case, it's actually articles that you've read. We've kept it pretty simple here. We've used local storage, which is a very basic, easy to use API. It gives you basically just a JavaScript object. Local storage, you can use it, you can treat it as just a JavaScript object where you can say local storage.foo equals bar, and later on you retrieve it with local storage.foo. And that's an object that only your domain can see. No other web apps can get hold of that, read it, and write it. And it's a very simple interface. That's why there are also these other ones that have actually got more complexity to them. They give you the benefits of speed and so on, but not quite as simple. So we've got that with Web SQL database. It's basically an entire SQL database sitting in the browser. You can imagine that's going to be quite complex. It does have great performance characteristics in terms of being able to search for a lot of data or being able to just do things asynchronously, which is the way a lot of the web apps work. But that's actually being deprecated. So it is actually quite widely supported as well in the current, because it's in WebKit, it's actually in the two apps that you've actually, or the two devices you've already seen here. But at the same time, it is being deprecated. It's never made it to mainstream use across all of the desktop browsers. So what now seems to be the way of the future is index database. It's already there in Chrome and in Firefox on the desktop, and hopefully it will make its way to the mobile browsers soon. And it kind of gives you the best of both worlds. A lot of the simplicity you get from local storage, but the speed and performance characteristics of Web SQL.
So we said before, each of these devices, they have a marketplace, a store built in for users to go and find applications. Luckily, the web is no different. But let's just kind of jump back to our idea of having a consistent common URL structure. It's really important. We can't stress it enough. If you combine a consistent URL structure across your app on the client side and the server side, using HTML5 history and potentially the dual-side templating, it's really easy for search engines to go and aggregate your content. If it's an entirely client-side application, it's really hard for search engines to be able to go and do the job that they do best and deliver users to your application. But it's not always about just search engines. You know, each of these devices do have native marketplaces on. You can use services such as PhoneGap, for instance, to actually just package your application. Package your application up into, it's an existing web application. You can use it, package it up, and then deliver it into these native marketplaces. But again, it's not just about native devices. There are a lot of different web stores. If you're building a desktop application, I think Seth was talking about it yesterday, or there was a talk about it yesterday, about the web store. Chrome Web Store is a great place for you to go and get your applications discovered. But from the mobile context, there are a lot of other third-party web stores available. It's just relatively easy to get into them as well. So we have a whole range, a whole spectrum of different ways to get your application discovered from traditional search engines. The power of the web is that these search engines can index your data, but then you can also go a little bit more native.
Touch. We want to get our apps working with touch the same way the native apps do. And it's amazing when you think about these gestures, things like swiping and pinch to zoom. When you use a device these days, they feel so natural, but they've only been around for a couple of years. So it is something that actually just works with the way we think as humans, and I think we want to be able to cooperate with that thinking and actually implement that in our apps. Fortunately, we have this again with HTML5, and you've seen it in the IO reader layers, the ones that are actually specifically related to touch devices. We have this with touch events. So we don't have to work around this like the earlier browsers were doing with your old school mouse events. You've actually got built-in touch support with events like touch start and touch end. As far as those gestures, those things like swiping and fling and pinch zoom, those are starting to come into the standard. They're not all there yet. So what we did in this app is we created a little library to help with it that would actually detect when the user's done a significant swipe action, significant enough to actually register and respond to it. So this is actually a little library where you attach it to an object, also jQuery based, and it actually will fire when the user's actually done that swipe action in one direction and let go, whether it's horizontal or vertical. It also fires as the user is moving their fingers back and forth, so that you actually saw the stories being swiped back and forth on the phone or up and down. So we actually can respond to that as the user's doing it, which is a much better way to design user interfaces than 5 seconds later. And we can also do click, which is what happens when the user opens the article, and long hold. We need to implement those things because if we're capturing all the touch events, they won't always fire. The actual built-in click event won't always fire, so we need the library to do the whole thing. We actually found it really convenient to develop a lot of this app on the desktop, even in the case of the phone API or the phone form factor, because the desktop is where you're actually coding, so it's really easy to be able to switch windows and see how the app is working. And it's also where you can actually take advantage of tools like the Chrome Dev Tools to actually do your debugging. So to that end, we actually built into this library a few switches to make sure that it will work nicely with mouse events as well if there is no touch support there. And also just a tip about debugging is you can actually debug on the device. We were doing that in the later stages of this project. And with Android, it's actually really easy. There's a URL up there where I've just put a few steps in. Just to attach your device by USB, or you can do the same thing on the emulator. And you just have to run a couple of commands, and in a couple of minutes, you've actually got console logging there. You can log your own messages, and you can also see error messages coming from the browsing environment. Just a final note and a bit of a caveat on this whole area of touch interfaces. It's really easy to fall into the so-called uncanny valley. It's a term from robotics that means you've got kind of close to there, but eerily slightly not there, and something's just a little bit off. So the recommendation here is try to stay right away from that. If you don't think you're going to get very close, just make something that's very different. There are many successful apps you can see on the various mobile marketplaces, which are a very idiosyncratic interface. You see a lot of games that devise their own mechanisms for menus and so on. It is actually possible to do that. You don't have to emulate the native look and feel. So if you're going to do that, stay clear away from it. If you're going to do what we've tried to do here, we recommend taking the time to make it as close as possible so you don't end up in that weird middle ground.
So we mentioned early on about the form factor detection and how the differing interaction styles that you have for the different types of devices is really important. However, in each of those classes of devices, there are a whole multitude of different screen sizes and different capabilities, and how do you actually build your applications to cater for that? It's actually quite simple in the end. The first thing that we did in our application was we defined a viewport. The viewport is basically there to stop the existing web from completely breaking in mobile devices. So it defines this kind of, it basically pretends to be like, say, a 1024 by 768 browser, so that the pages can render correctly, and then it'll scale the page down to fit the screen, or allow you to zoom in and zoom out so that you can pan around it and not actually have to have the web developer of the existing site, cater especially for your device. But when we're building these applications, we don't want that functionality. So it's relatively easy. We're basically just saying this virtual viewport has to be the exact same size as the device width. And that basically allows you to get sometimes a near one-to-one correspondence between physical device screen size and what's reported to your application. But you still have the ability to enable zoom and zoom out and all the kind of traditional pinch-based gestures inside your application. We chose not to do it in our application. We said, we're specifically targeting smartphones. We're going to design our application to work well across all these devices. We don't need to have zoom in and zoom out and the traditional pinch gesture. So we've disabled it. But it's how to say this? It's entirely up to you. If you have an application which is suited to zoom in, zoom out, and the native those native abilities, keep them in. We chose not to do it in our app. And the next is media queries. With form factor detection, we're definitely not trying to get rid of the idea of media queries. We're just trying to make it more manageable for us to build applications that are responsive to the different screen sizes. It's a lot easier to build an application that will respond to different smartphone screen sizes or different tablet screen sizes than have to have one that, basically one style sheet that responds to all of them at the same time. And media queries are just a great way to build applications that are at least aware of the type of screen, the size screen that they're on. And in our case, when we showed the demo of the smartphone, we had two different orientations, a portrait and a landscape. You can just target different CSS to say, the landscape mode. It maybe hide some images because you value vertical space. And then in the portrait mode, you just go and show all the images because you've got a lot of vertical space and there's a lot more freedom in that mode. So we're actually getting quite close to the end. It's, so we're just kind of, all those images are gone. Cool. So they're supposed to be nice ticks. We've solved them. So we think we've done an okay job at solving these 6 different interaction styles, or 6 different problems of, that we face as mobile web developers. The different interaction styles are managed through form factor detection, so you can target specific user interaction styles to the different types of devices. We've shown you how single-page apps, traditional AJAX methods, can really help improve your application just by incrementally loading the data and not having this jarring experience when you're navigating from one page to the next. And then with...
See if I can do a reload. Nope.
Sorry, yeah, no worries. And then using app cache, not only can you make your application load instantly, you can just make it work offline as well. And then if you combine that with local storage, you can at least keep the data in memory and in browser so the user doesn't have that experience of being completely offline. We can make our applications discoverable. Things like the server-side templating and the client-side templating, the dual-side templating techniques we talked about, allow you to render and present data to search engines really efficiently, get that, and get discovered. And then you can obviously use the native frameworks as well to actually package your web application. We've shown you how you can build applications that are responsive not just to basic touch commands, but the gestures as well. There's a nice little library micro. And then just using viewport and then media queries, we can actually build applications that are responsive to the different screen sizes.
So the idea here has not been just about targeting the mobile devices, but about using this technology of HTML5 to reach all of the different types of devices you might care for, to expose your services to the users. And to that end, we've also got these other types of apps as well. So we've got a desktop app. So this is not the desktop app. That's the TV app here. So I'll show you the TV first. So this is actually where we've got the TV, where it's that experience where you're 10 foot back. You want to just get a bit of an overview about what the stories are. You can see them easily. And taking into account the user interface on the input side and the output side. So on the input side, I'm able to control all of this. I can use a pointing device if I want, a mouse. But I'm able to control all of it just with the keyboard, with just the arrow keys, which you would have on a very basic remote control. So that's the input side, and on the output side, you can see how it gives you that very big overview. And in the case of the desktop app, layout problem. Okay, I'll leave it to the screenshot. You can see that later. Sometimes with the offlining, it can be a problem where if it's a slow connection, which seems to be the case here, I think, you can actually get something going. So, we can switch over to here. So sometimes you'll get a situation where it downloads some of it, but not all of it, which we haven't optimized for. But you can see it here. So you get the ability to use keyboard shortcuts, which kind of fits in with the natural style that people tend to assume should be there on the desktop, as well as the mouse. So again, it's that input style of keyboard shortcuts and mouse, and the output style just taking advantage of all the features of a standard desktop browser. Let's jump back. And the point about this has been that we were able to develop this all quite independently from one another. So we actually, Paul did most of the work on the architecture and the core logic of the app. And each of us wrote the separate layers. 2 of us were in London, 2 of us were over here in Mountain View. And we didn't have to do that much communication between each other because it was just a standard contract for how we'd actually write these apps. So you can see here, the vast majority of the logic in IO Reader is able to be reused. And I think that's about it. So you can see the code's going online. The actual news source that you see, it's coming from the Guardian API. It's probably going to be one too many hits for their API if we leave that running. So it's really something where you can actually plug in your own data source, and you could actually do something for your own apps or for any other kind of services that are on the web. That's a separate module that's part of IO Reader on the server side. That's a node component that you can actually write your own to get different sort of data. And there are various open source libraries as well that we've used in here that you'll be able to see. The slides will come online. You'll have all those links. But for right now, we've got a link to Moderator. I don't know what we did. There's another one that doesn't work online. Maybe we can switch to the link on there. So if you jump onto the link, we're just going to jump to the link that we've got in the slides. But meanwhile, we do have time for questions, and we're interested to know, like, if you've got any challenges you've come across or any other tips, we'd like to hear about them. So please, if you've got questions, come up. Otherwise, we'll look at moderator as well in a moment once we're back online.
Hi.
Hi.
Can you talk about the interaction between the manifest file and which files are downloaded compared to the script tags and the style tags that are in the head compared to the that slide you showed with Modernizer, which actually selects which styles.
Right.
Yeah, so we didn't have an amazing amount of scripts inside our application, so each individual form factor is actually embedded in the one sheet. So if you look at the code, it's maybe two bits of JavaScript for smartphone, 2 files for desktop, and we just download all of them because it's relatively low latency at the moment. This actually allows you to quickly flip in between the form factors and then not have to re-download any new assets and invalidate your app cache.
And so does the manifest file, all of those files get downloaded and they're all referenced in the head as well?
Yeah, they're referenced. Well, there are some core assets that are referenced from the head. The common controller is in the head, and then each of the phone JavaScript and the iPad Java or the tablet JavaScript at least is referenced in the form factor loader. Because it's on the server side, we have control over what gets rendered where, so we know all the files that are needed for the whole entire application. So they are always available at the moment.
Let's take one from moderator.
Yeah.
Or you.
So, should we just do one from moderator?
Yeah.
So we'll just pick the first one, jQuery Mobile, Sprout Core Mobile, Sencha Touch. What's being used? In our application, we didn't use anything specific. It was just all normal JavaScript. But, everyone, would you want to explain the differences? You probably...
Yeah, and briefly, the differences between these 3 frameworks, I guess jQuery Mobile, it's a very new framework. It's got a very permissive license, and it's very much like jQuery, very much a microkernel with some very basic sort of widgets at the moment and the ability to do theming as well. But it's very much a standard sort of open source project like jQuery. The other 2 are more commercially backed. In fact, both of those, Sprout Core and Sencha, are here at I/O in sandboxes if you want to talk to them. Their Sprout Core is aiming to be an app where you can sort of write just HTML, focus on something that might even be desktop related, or actually take advantage of some of their widgets, and then they're aiming to offer services on top of that. So it's, I think, a bit of a less commercial license because it's not dual license like Sencha Touch. It's also got the MIT license like jQuery, so you can use it however you want, and then they're planning to sort of add extra services to it, like being able to package things up and distribute it to stores and do caching and so on. And Sencha Touch is starting to become a very big commercial operation. You can still use it as a GPL3 license. They've got some very sophisticated widgets available. So as always, horses for courses, and check them all out.
Yeah.
My question is in regards to the offline of a web app. If I had an app where a user could post, let's say, information through the web app, and they were offline, is there a method or a technology that then the device or the app would recognize they are online and push that back to my site or the app?
Each of the devices normally has an event. I think it's online, online is an event on the document, so you can at least tell when you're on. It doesn't work across all devices because it depends on whether the network interface is up.
Yeah, and that originally wasn't supported on Chrome because they had the intuition that you should actually just be trying to push it online, and if it doesn't work, you handle the exception.
Yeah. So one thing we do in our application at least is we don't necessarily post any data, but we intercept every request as best we can for fetching the data so we can then cache it. I think the same thing applies when you're trying to post data. You can basically get the on error states on XML HTTP request. And then respond to it that way, and then just make sure that data's cached. But client side, I think.
It makes a good point because we need more libraries to do this sort of thing. Yeah. We're starting to get some libraries like Lawnchair and Persist.js that will eventually have different layers probably to sort of fall back depending on what mechanism is there for local storage. What we need is actually higher level libraries that will do things like caching and syncing. They're not really there yet in the JavaScript world.
Thank you.
Cool.
This isn't a question, it's just a comment about console.log. Console.log on Android is not universal to every single Android device.
Right.
For example, the HTC, most of the HTC lines, not the Nexus one, but the commercially available HTC lines do not have console.log. That's why it's a good idea to actually develop your mobile application in the the emulator instead of the device in this one case.
Yeah.
So I figured.
Good advice.
There's also, it's actually interesting, you can do about:debug on some of the Android devices, and then you can get if it supports the console, you can actually get a console log inside the application on the device as well.
Try it now. You just type about debug and use it to toggle on and off.
Yeah. Cool.
Yeah, well, let's take one actually from moderator first. Yeah.
Which one?
So the next one is what's your take on app versus mobile website?
Depends on the content, I think.
It does, yeah.
If it's content-based, it's a site. If it's functionality, then it's more app-like.
Yeah, and I think we've seen the same thing because Paul and I have worked a lot on the Chrome Web Store. I think it's also about being aware of the fact that apps do have special privileges. They can do things like in-app payments easily, and maybe they've got other ability to get involved with the hardware and so on. They can also communicate back and forth. There are techniques that you can use on the various platforms, like the kinds of things PhoneGap does, that let you communicate with native capabilities. So if you actually do need to tune into those native capabilities, you can do that with apps as well. But I think there's always a role for websites, and actually with phones, you've got the ability to send an SMS with a link in it. So it's really convenient for people to just click on a link from an SMS, as well as they might see it in Twitter or something. All of those things don't open apps, they open phones. So you still need at least some mobile web presence.
Cool.
Yeah.
Hi, I have like a couple of questions.
Yep.
The first one is, what's the best way, like normally you detect difference between the phone and a desktop. Like usually you use the user agent.
Yep.
So is that the best way, or you go, what is the best way to handle it?
Yes, that's actually a really good question. So how do you actually detect the differences between the devices? We've actually used a combination of user agent string checking in the JavaScript side of things, but then specific media queries as well. So the FormFactor.js can take a whole load of different expressions that will determine whether it's a particular device class or not.
Yeah, in the case of FormFactor.js, we've left that kind of modular, so it's actually down to the community that doesn't yet exist, but that would be the concept, is you'd be able to have a whole grassroots collection of tricks.
We have like media queries like TV, and pretty much only TVs support the TV media query. So you can basically use that media query to say, well, actually, we definitely think you're on a TV, and then download these assets. But it's a combination of...
and it is always a messy approach. It's not very clean cut, so that's why we also provide the ability to jump back to the standard desktop app. And it's something that's a bit controversial doing this sort of thing, but we feel like the standard approaches that people talk about in terms of feature detection and responsive web design, they're just not enough to actually have quite distinct user interfaces for these different form factors. So even if it is messy, we'd rather have some sort of guess about the form factor.
Okay, and another question was like, normally in applications, if you have like sort of an event, like where you click, if it's a map coordinates, like you click and it will launch a map UI.
Mm-hmm.
So say for example, if I were to develop like something for picture, so if someone clicks and holds on the picture, if I want to raise an intent to set as a wallpaper or something like that, is there a way possible right now?
I don't know, it's Android specific.
That's kind of more Android specific,
yeah.
As long as it's got a consistent URL, I'm under the impression that the applications respond to when those intents are broadcast from inside your web application. But the other way around, I don't think you can, I don't think it won't launch the browser naturally unless the browser is actually listening to that intent.
No.
So.
Maybe I didn't clarify. So if I have a web application and I'm browsing like pictures, so from that, is there a way like to sort of like raise new intents as to if some application is registered for, say, sharing something like that, and if you click on it in the browser itself, and then you want to set it as you want to crop that wallpaper or maybe set as a wallpaper, so can you do that?
Not that I know of.
No. You just have the ability to do what we show, which is the share feature, but that's as far as I know. There are standards, so there are standard protocols for doing things like launching the phone. If you want to show a phone number, you can do tel prefix and so on, but not in a general sense as far as I know.
Thank you.
Okay, thank you. So maybe time for one more question.
Yeah, should we just do one more question from here?
We'll wrap up.
Any good example out there of a real-life HTML5 implementation that runs on desktop, phone, tablet with offline capability? Gmail seems like a poster child more than any others. So Gmail doesn't. IO Reader. That's a great.
Yeah, I think the real life was intended there for a reason.
Yeah, exactly. So this is one of the things that we're trying to do. We're trying to reach developers and help them build applications this way, because I don't think that many people are building those types of apps.
I'll give you a couple of examples. One interesting one to look at is Bitly. Bitly's own app. It works nicely on the mobiles. It does canvas graphics to actually generate charts, which is basically the same thing it does on the desktop, and it seems to be quite natural on both of those. And also look at Netflix. There was a long article on the Function Source blog recently about how Netflix is targeting over 400 different types of devices with HTML5. It's not really the same app, but it is actually the fact that they're using the same technology stack again and again, and based on HTML5, and specifically that they're actually aiming to keep it within WebKit. Yeah, I think we can probably leave it there.
Yeah. So actually, can I answer one about the push state?
Okay.
We've got a question about, is the window.push state history manipulation supported on all major platforms, or is it just a feature for future applications? It's not supported on every single platform at the moment. WebKit's got a really good coverage of push state. The reason why we created a wrapper library is because we can't always rely on the fact, well, this Levi Roots framework, we can't always rely on the fact that push state is supported. So the application, if you used links, you'd see it use the document fragment to indicate active articles and things like that. So that whole routing framework can take advantage of on-hash change or just normal on-load events as well to actually detect the current state of the application. So we haven't got full coverage. I think more browsers are going to support it because this, I mean, literally, it's the fact that you can have a single consistent URL structure on the server side, on the client side. It just makes it so powerful.
Okay, so let's take one final question from the audience here, and then we'll wrap up.
Thanks. How were you using Mustache? Were you actually sending different markup to each client and like transporting JSON, or what? Was it all CSS based?
Actually, we've got the same consistent HTML DOM structure throughout the whole of the application and across all of the different types of devices. Mustache was just there to, when we get data back from the article, so we will go make a request to the Guardian API, and then it's in its own format, and we like munge that into a consistent object model for our side. If it's an AJAX request, it's JSON to the client and then rendered using that same template that is held on the server side. And the server is, again, because it's all Node and it's a JSON object, we just basically render the same thing.
But the reason we use Mustache, because it's all Node, we could have used anything, right? Because it's actually JavaScript on either side. We just used Mustache really as a proof of concept. We wanted to show that even if we did our server in Python or whatever, we'd still be able to use that same pattern of taking the same data structure, but on the server, the data structure is like a raw data structure. It's not really represented as a string of JSON. It's just a data structure that gets pushed into the Mustache library, whereas on the browser, it is actually JSON that gets pulled down by XHR and processed on demand as the user actually requests that content. Yeah, I think we're done. Okay.
Cool. Thank you.
Thank you.